Space is vast, it's filled with stars, planets, and galaxies. But there's more, much more. Most of the universe is invisible. We call this mysterious stuff dark matter. It's like a cosmic shadow play. We see the effects of dark matter, we know it's there, but we can't see it directly. Dark matter doesn't emit light, it doesn't reflect light, it doesn't absorb light. It's a cosmic phantom lurking in the shadows. Dark matter is different from ordinary matter. Ordinary matter makes up everything we see. Stars, planets, you and me, all made of ordinary matter. Dark matter doesn't interact with light. That's why it's invisible. It also doesn't interact much with ordinary matter, it passes through us like a ghost. We know dark matter exists because of gravity. Gravity affects everything, even things we can't see, and there's a lot more gravity in the universe than we can explain with ordinary matter alone. In the 1930s, Fritz Zwicky, a Swiss astronomer, noticed something strange while peering through his telescope. He was meticulously studying galaxies in a cluster, carefully measuring their speeds and movements. To his astonishment, the galaxies were moving too fast, far exceeding the speeds he had anticipated. According to the laws of physics, their incredible speeds should have flung them out of the cluster, dispersing them into the vastness of space. But they weren't. Instead, something invisible, an unseen force, was holding them together, defying the expected outcomes. Zwicky called this mysterious force Dunkle Materie, which is German for dark matter, a term that would become pivotal in astrophysics. Decades later, in the 1970s, another astronomer, Vera Rubin, made similar groundbreaking observations. She focused her research on the rotation of spiral galaxies, meticulously analyzing their behavior. Rubin discovered that the stars at the edges of these galaxies were moving too fast, much faster than expected. Once again, it was clear that something invisible was providing the extra gravity needed to hold these stars in place, an unseen force that continues to intrigue scientists to this day. Section 4. Seeing the unseen, detecting dark matter. Dark matter is one of the most mysterious substances in the universe. It doesn't emit, absorb, or reflect light, making it invisible and incredibly difficult to detect. We can't see dark matter directly. It doesn't interact with electromagnetic forces, which means it doesn't produce any form of light or energy that we can observe with our telescopes. But we can detect its gravitational effects. Dark matter exerts a gravitational pull on the objects around it, influencing the motion of galaxies and the behavior of cosmic structures. One way is through gravitational lensing. This phenomenon occurs when a massive object like a galaxy cluster bends the light from objects behind it, much like a magnifying glass. Imagine a bowling ball on a trampoline. The ball creates a dip in the fabric, and any smaller objects placed near it will roll towards the ball. Similarly, light passing near a massive object bends due to the gravitational pull. It creates a dip in the fabric. Light passing nearby bends. That's gravitational lensing. This bending of light allows us to infer the presence of dark matter even though we can't see it directly. Massive objects like dark matter can act as lenses, bending and distorting light from distant galaxies. This effect can magnify and distort the images of these galaxies, providing clues about the dark matter's presence and distribution. By studying these distortions, we can map the distribution of dark matter. Scientists use sophisticated computer models and simulations to analyze the patterns of light bending and to estimate the amount and location of dark matter. It's like seeing the invisible through its gravitational shadow. This method has allowed us to gain a better understanding of the universe's structure and the role dark matter plays in shaping it. Section 5. The Mystery Particle Hunt. In the vast expanse of the universe, there lies a profound mystery that has puzzled scientists for decades. What is dark matter made of? This question has led to one of the most intriguing hunts in modern science. We don't know for sure. Despite its elusive nature, dark matter is believed to make up about 27% of the universe. Scientists have proposed many candidates. These candidates are theoretical particles that could explain the gravitational effects attributed to dark matter. One leading candidate is WIMPs. WIMPs, or weakly interacting massive particles, are a popular theory. These are weakly interacting massive particles. They are thought to be heavy and slow-moving, making them a prime suspect in the dark matter mystery. They're hypothetical particles that interact very weakly with ordinary matter. Another candidate is axions. Axions are a different type of particle altogether. These are even lighter hypothetical particles. Unlike WIMPs, axions are incredibly light and could behave very differently. They're thought to interact even more weakly than WIMPs. This makes them even harder to detect but no less important in the search. The search for dark matter particles is ongoing. Around the world, scientists are using advanced technology to try and detect these particles. Scientists use sophisticated detectors, buried deep underground, hoping to catch a glimpse of these elusive particles. These detectors are shielded from cosmic rays and other interference, making them ideal for this delicate work. The hunt continues as each discovery brings us one step closer to understanding the universe's hidden mass. Section 6. Dark Matter's Cosmic Scaffolding. Dark matter plays a crucial role in the universe. It's the invisible scaffolding upon which galaxies are built. In the early universe, dark matter's gravity pulled matter together. This created the seeds for galaxies and galaxy clusters. Without dark matter, galaxies might never have formed. Dark matter's gravity also affects the motion of galaxies within clusters. It holds them together, preventing them from flying apart. Section 7. Unraveling the Dark Mysteries. Dark matter remains one of the biggest mysteries in astronomy. It's a humbling reminder of how much we don't know about the universe. The search for dark matter is a quest to understand the fundamental nature of the universe. What is this mysterious substance that makes up most of the cosmos? Future discoveries in dark matter research promise to revolutionize our understanding of the universe. It's a journey into the unknown, a cosmic adventure that continues to unfold.